Okay, great. Welcome to the workshop. This is Dive into Object-Oriented Python. It's a long workshop. It's 3 hours, but I will try to respect the breaks. Marlene imposed on me. Yeah, just joking. So first of all, this workshop comes from a set of posts that I wrote. So what I want to say is today I won't cover everything because there is a lot to cover. Okay, so I will just give you glimpses of what object-oriented is in Python. We will try to understand some of the tricks and the main things. I'm always available later after the workshop, so get in touch. Okay, without further ado, I will check here sometimes if we have questions. Okay, this is the workshop. About me, very quickly, because I don't have that much time, I'm just an engineer. I like Python, I like many things. I blog on the Digital Cat Online. This is my blog. And I mention it because if you want, this whole workshop is available here as a set of 6 posts that I wrote some time ago. So if I skip something important, if something is not clear, you can just head to my blog and read it and then get in touch. What you will learn today, I will touch on these things. So first of all, the principles of object-oriented and the reasons behind them, why we are using object-oriented more than 40 years after it was conceived, and how Python implements object-oriented, and some of the magic things that happen behind the scenes, and the meaning of words like class, instance, attribute, inheritance, composition, many others. I won't cover metaclasses. They are far too complicated for the time we have, and they are not that important for your career as Python developers, at least for the initial one. As for the schedule, I'm already late, but I will cover the intro, which I'm giving now, and the first part in this first hour. Then we have a break, second part, a break, and the third part. I will try to finish for 2 and to be respectful of the timing of the conference. Questions? No questions. Okay, great. Okay, as for the workshop proper, so if you installed the Jupyter notebook that I sent instructions, so if you have it, you can just run the Jupyter notebook command, and this will open the notebook here. So this is what I'm going to use for the workshop today. I invite you to run the same thing on your computer and to try and follow along. Also, the exercises are are here, so I will read the exercises, give you some time to perform them, to solve them, and then give you my solution. Please remember that my solution is not the solution, so it's one of the solutions. Sometimes it's the only one. Sometimes it's just what I think we might do. Okay, let's go. I hope you're ready. Cool. So object-oriented programming. Where do we start? Let's start with this. There is no prior knowledge that you need for this workshop. You just need to be able to fire up Python and conceive what a computer can do. This is what happened in the 60s, 70s. People were like starting using computers. They were starting doing things like this. So they were putting data into computers. Like this is a tuple in Python, but after all, like a list, a tuple is sort of the same thing. It's just a bunch of data. And they were creating functions to work on those values. So in this case, if you don't know Python notebooks, very quickly with Control Enter, you can run a cell So this is what I'm doing now, and I'm running Control Enter. I'm running the cell. So this, as you can see, this works. Okay, it's pretty easy. We define data, we define a function that accepts that data and returns, in this case, the average, you know, the sum of all the data divided by the length. And this works, I hope. And so far, so good. We went to the moon with this. So pretty good. The problem is that then we go on and we try to create data and functions that can change, modify the data. So in this case, this is the example I will, you know, give for the whole workshop. I created a lift. It's like, you know, a model for a lift in a hotel or something. We have the floor, and we have the status of the lift. You know, if the doors are open or closed. That's it. So I define two of these type of data. Then I define a function that prints these values, which let me execute them. This works, okay? Lift is at floor 1, doors are closed. And then I define a function that is a bit different. This changes the value inside the lift. And it works. Okay, now the lift is at floor 1 and the doors are open. What's the problem here? That when I define something, don't look at the duck here. When I define something different, like a security lift, let's say I want to define a slightly different type of data, right? So I have 1 closed. These are the flow and the status. But then I define a lock unlocked value because I want this lift to be, you know, it is lockable, basically. You know, I can lock it and I can open it only if it's unlocked, which is what happens here. I define open security lift. If lift 2 is unlocked, then lift 1 is open. Nothing complicated. And it works. Yes, it works. What is the problem that I see as a programmer, as a designer? Then here you have to keep in mind, as a programmer, you have to keep in your mind the connection between lift and open lift, and security lift and open security lift. And this is problematic because, well, you have to keep it in mind. You have to remember it. If you use open lift on a security lift, things are not working. Maybe it works, but it doesn't work well. Okay, so what people thought in the late 70s, in the 80s, one of the things they thought was, okay, if I can keep it in mind, if I can remember it, why can't the computer do it? So this is where object-oriented starts. And this is the first part of the workshop, encapsulation. Can we keep data and functions together? Instead of dividing them, we keep them together in something so that we don't have to keep in mind the connection between them. Let's check. No questions. Okay. So let's go on very quickly. I said type a lot of times here. So I said I create a type lift, I create a type security lift. What is type? Okay, let's look at this. I believe everybody agrees this is a duck, right? Why do I say this is a duck? Because it looks like a duck, right? And if this was a movie or like an animated GIF, you would see it moving around like a duck. And that's fine. So I say the type of this animal is duck. Why? Because it behaves like a duck. Okay, it behaves in terms of how it moves, or it behaves in terms of how it looks like. But then I catch the duck because I want to prepare a meal. Sorry, vegetarians. And, and what I discover is that the naked truth is that this is instead a very sophisticated, well, robot, right? So this is not a duck. This is a robot. So suddenly I say, oh, the type of this thing is not duck, but it's robot. What is the difference? Why did the type change? Because now I'm looking at the structural meaning, how it is internally. Okay, so let's keep this in mind. That's enough for now. There are two definitions of type: the structural meaning, how something is made internally, and how something behaves. And is that the behavioral meaning is important. It's not that we don't care, but we value much more how things behave, much more than how they are. So when we say in Python, this is a list, we usually mean this behaves like a list. We are not saying this internally is a list. This might be something different. We will have examples later, but keep this in mind for the whole workshop. The behavioral meaning is important, okay? That's enough, I believe. Whenever you hear duck typing in Python or in other object-oriented programming languages, this is something that Alex Martelli came up with in 2000. It means, that you take something like the robot and you make it behave like a duck. As you see, the problem is the behavior. More on this later, hopefully. Okay, just since commas are important in Python, in English, this is a duck typing. Okay, so this is not what we are talking about. It's just a joke. Sorry, just to give you a fun time before we dig into the workshop problem. Okay, so let me head to, this was about object-oriented. Let me head to the first part of the workshop itself. I have 45 minutes. Okay, so the good news about objects. Objects are what we invent, what we come up with to keep data and functions together. That's it, okay? This is what allows us to keep this connection. And you already used objects. Whatever you did in Python, if you just fired up your shell and you typed, a equal, sorry, let me run all these sets. If you typed a equals 6, then a is an object. It has a type. Do you remember? Behavioral meaning. Type of a is int. It behaves like an integer. It is an integer. And you can also use the type as a function to create something of that type. Okay? I hope this makes sense. One other thing that you already know probably about objects is that they have functions, and we call them methods. A method or function is the very same thing. It's just a method is a function that that belongs to an object. Okay, but it's really a function. As you can see here, there is a connection between the data and the function, because you are not running upper on welcome, but you are running upper of welcome. That's subtle, but it's different. Since I don't have that much time, I'm gonna skip the first exercises. Sorry, they are very simple. I'm giving you the solutions directly. They are really simple. The next exercises are more interesting. These exercises are like this. Find some types that Python provides out of the box. The hint is use the function type on some values. So what I do is, sorry, I'm jumping around. If I do is, what I do, or what I did, was to run type, the function type, on values like 4, 4.5, a string with double quotes. These are all things that you might be already familiar with in Python. You see, these are built-in types that Python provides. And this is interesting. We can know what types are in Python. The exercise number 2 was, can you create a float variable without using the dot character? So you can't write a equal 5.4. And which works, but you are not allowed to do it. And the solution is to use float as a function. So remember that this is important. You can use the type as a function. You can use it to initialize something of that type. As you can see here, I'm using an integer and I'm getting a float. And the third exercise, very simple, is what is the difference between these? I'm not gonna read it, it's complicated, and these other thing. How can you tell it? Again, you can use type and say this is a set and this is a dictionary. Okay, that's it. Very, very simple. Don't worry, it will be complicated later. Yes, I can leave. Let me move on classes and instances. Okay, classes. What are classes? What are classes and instances? So we understood what an object is. Let me see if there are questions. No, okay. Actually, yes, I'm looking at the right thing. So what are classes and instances? Let's say this. If I say there is a house with a door, if I say this, you immediately understand what I'm saying, leaving aside my accent, but you understand what a house is and you understand the door, right? You picture it in your mind. But I just mentioned a generic house and a generic door. So each one of us pictures something different in their mind. Well, if I show you the door that is in my room, well, that is a concrete door. It's real. It has a specific color, has a specific handle. You can't just think it's red. It's not red, it's white. Okay? This is the difference between, I hope it's clear, between classes and instances. So classes are ideas, right? So when I say house, it's an idea. You know, what is a house? It's the building. It has probably windows, doors, you know, a lot of space, a kitchen maybe. This is the idea. But then we have a concrete instance of the idea. The instance is something that we can touch, and it's different from another. Okay, I hope this is clear enough. The first class that we have, you probably already wrote classes in Python, but let me indulge me in this. I'm going a bit slowly. The class is a collection of data and functions. Everything that is under the definition class is part of the class. These are functions. We call them methods. But as I said, they are exactly the same thing. The only difference is they accept self. I'm going to tell you in a second what this is. And I can, if I run this thing, I can use this name, lift, the name of the class, as a type. You remember I used float to create a float value, and I can use lift to instantiate. This is a complicated word. Instantiate means to create an instance of this class. Now I have lift1 is an instance, lift is the class. As you can see here, I pass values. And the values, this is something that happens internally in Python. It's implicit. This calls the method init, passing these two values as these two arguments and doing something here. What might not be clear is what happens with self. What is self here? Self is the instance that we are creating. So the class has access to the instance that you are creating. As you can see here, lift is creating self, so this instance here, and is passing one enclosed, putting them into the instance. Okay, so now lift1, which is self, has a floor, which is 1, and has a status, which is closed. Okay, this closed goes here, goes into self status, which is this one. I hope this is clear. And when you run lift1 open, which is this, as you can see, you run it on the instance, but the method is defined in the class. This is important. We're gonna investigate this a bit later. What happens is that open changes something in self. Again, self is the instance that you are dealing with. And open works. Okay, so if I do it, the status changes to open, from closed to open. So to recap quickly, classes, ideas, collection of a behavior. Okay, so the classes say the door is something that rotates on hinges. It has a handle. In this case, the lift has a floor, has a status, you know, but these are generic things. And then you have an instance which has the proper values, one and closed. And when you run the method, these values change. Okay, cool. Really, I hope this is clear. Let me give you some exercises. Here we are. So here we go. Okay, so I'm gonna read the exercises now. I'm gonna give you some time to run the exercise, to solve them on your own, and then I give you the solution. In the meanwhile, I will try to see if there are questions. Let's go, and then yeah, get in touch with me if something is not clear. Exercises. Exercise 1 is using the lift class as an example. So this thing, you can just copy it. Create a security lift class that has the floor, status, and locked attributes. Don't use, if you know how to use inheritance, don't do it. Don't do it. Forbidden. Okay, inheritance doesn't exist because we haven't studied it yet. So don't do it. Just create something, say class security lift colon, and then go on. Okay, copy this thing, change it a bit. So you need these 3 attributes. As I said, you're forbidden to use inheritance. Exercise 2, create a closed lift class, so another class that has a default status of closed. And the third one, create a toggle lift class that has a method toggle, which toggles, you know, between open and closed. If you haven't used Python notebook, Jupyter notebook, so if you press Alt Enter, you can create a new cell, and then you can type Python here. Okay, so you can do class security lift secure. I can't type security lift and so on. Okay, security. You have some time. Let's say 5 minutes to do this, and then coming back with the solutions.
Leonardo, you have some
Yes.
questions in the stage chat. You just take a look at that. Thank you.
There is a question here. Where is it? Oh, chat. Sorry, this can't see it. Stage. I'm sorry, guys. I'm really stupid. So is this the question you're asking? Sorry. So yeah, you don't have to use Jupyter notebooks. No. That's fine if you want to do it on the Python shell or U editor. It's just, Python notebooks are, I don't know, they are good to do these things because you can write text, you can write your Python, but yeah, definitely this is pure Python. Okay, so Python 3, but that's it. Python 3.1 is perfect. I hope I answered the question. And sorry for looking at the wrong chat. Apparently, I'm not smart enough to use the online tools. Okay, let me go on with the solutions. Here we go. So, okay, as for the first one, using the lift class as an example, create a new class, security lift, that has different attributes, so floor, status, same thing, and then locked. Okay, as I am forbidden to use inheritance, I just rewrite the whole thing. So class security lift, I define an init method, and the init method has to receive self. Okay, so you have to pass it, otherwise nothing works. And then I created these 3 attributes, F for floor, S for status, and L for locked. And I put them into my instance. Okay, so suddenly my instance doesn't have only floor and status, but also locked. Open and closed are the same. This doesn't say anything. Okay, so let's see if this works. I can instantiate this as a lift. No, I can't. Why? Because I added an attribute here. So here I'm passing 1 and closed, and this wants another attribute. So this doesn't work. It's correct. This works. Now L is a security lift. Okay, so if I say type of L, yeah, main security lift. Okay, leave aside the main. That's not important. Security lift is the important part. As you can see, the important part of the exercise is the type, the class, behaves as a method in itself, and it says, internally using init. The second exercise is create a closed lift class that has the default status of closed. So I said methods are functions. So as they are functions, you can use default values. So it's just a matter of creating another class with the init, and then saying F is just the floor, the standard thing, but then S has a default value. How does it work? Well, when I instantiate closed lift as a lift, normal thing, passing floor and status, well, everything works. Okay, so this is the status, perfect. We are okay with this, but if I pass something different like open, that works. But now the but, if I just pass the floor, this works as well. Why? Because internally this uses init, and init wants just self, which is passed automatically, remember, F, which is given here, and then since S is not given, well, it receives the default value. Okay, so remember, objects are a bit complicated, but eventually, so they are just a collection of methods, and the methods are functions. Same thing. Okay, Exercise number 3, and then I'm going to look at the questions, hopefully the right chat this time. Create a toggle lift that has a method toggle that toggles between open and close. Again, very simple. I create a new method here, and I just use the values that I have inside my instance. So let's see if it works. I can instantiate it, giving 2 values here. I can read the status, I can toggle the status, and then the status is different now, okay? Just to see that you can add methods to your classes. That's it for these exercises. Let me close these, and, well, let's wait and see if the... Yeah, keyword arguments. Okay, about keyword arguments and argument. I know I'm not going to touch those things, but yeah, methods are functions, so you can use star args and star keywords. That's perfectly allowed. You can see this in many libraries. Again, that is just a way for the function to collect the arguments and pass them, right? So this works with methods as well. Cool. So let's go on. I'm on time, fortunately. Instances. Okay, so now we discussed, classes, ideas, instances, concrete objects. We wrote a class, and then it's time to understand, and this is very important. It's time to understand the connection, some of the quirks of instances and the connection between instances and classes. This is paramount in Python. I saw so many people who are not beginners not grasping exactly what happens here. And to be honest, this is, if I can give you my personal witnesses, I used Python for many years before I started thinking, really, what's going on here? So what are the internal mechanisms? And I started studying it. So, okay, sorry, I'm rambling. Instances. First of all, instances are writable, and this is so important. So let me run all these cells. Oh, sorry. This goes to the bottom. Here we are. Instances are writable. Okay, so what I did here, again, you might be bored by this example. Sorry, this is the example of my workshop. Class lift. Same thing. Floor status, open, close. Nothing new. I instantiate it, and then I can read the floor attribute. It works. I can also write it, which is something you might have expected, right? I can say floor is 42 now, suddenly, and this changes. Perfect, fine, it works. Okay, we are confident, but pay attention. You can create new attributes on the fly. So if you say lift one color, and remember, color is not here. There is nothing. If I say lift one color here, it doesn't work. But if I create it, giving a value, suddenly lift one has a color. That's a very nice color lift, right? Why is this important? Because in Python, how many times it happened to me that I mistyped an attribute. I wanted to, I was here, I wanted to, sorry. I'm destroying this thing. Let me start again. Okay, here. I was trying to say, I don't know, lift one floor is 100, but I mistyped this. I say floor with one O instead of 2. I just mistype it. It happens all the time. And your editor might detect it, but you might not notice it. If you do it, this works. But then when you go and in your code you say floor, well, suddenly this is still 1. So this is why it's important. Remember that you can create attributes on the fly. This is very powerful in Python, but it's a double-edged sword. It's also very dangerous. In C++ or Java, for example, you can't do it. So when you say my class has a floor and a status, that's it. You can't create attributes on the fly. Okay, enough about this. I hope it's clear. Python instances are not connected to each other. This is simple to understand. So if I create two instances with the same values, both one and closed, they are not connected. What does it mean? So if I check where things are in memory, this is a computer, so Python is creating objects somewhere in memory, and the address in memory, not that we have to know exactly where it is in memory, but it's interesting to understand this. These objects are somewhere. If I use the ID built-in function, I get this strange number that is somewhere in memory, okay? And as you can see, lift1 is somewhere in memory, and lift2 is somewhere else in memory. This is comforting. So even though they have the same values, they are not the same thing, okay? They are not connected. And if I change the attributes in the first one, the same attribute in the second one doesn't change. This is, okay, well, I mean, just to reiterate, Python behaves correctly. And instances have introspection. This is a very powerful thing in Python. If you run, for example, the dir built-in function, you can see there is a lot inside this object. Now, look at dir. Look here. So we have, these are old friends of ours. Status, open, flow, close. We define them, right? They are part of the class here. But as you can see, there are so many other things. Overwhelming class, del, attribute, what are all these things? We are going to discover it in a second, some of them at least. The important thing is that you can look into the object and see what you have. And this is important because I asked myself at a certain point in my career, how does Python know the class of an object? The class of an instance, actually. So it's very simple. So if you read the dunder class attribute, if you don't know this, all these attributes, all these methods begin with 2 underscores and end with 2 underscores. So I might call these underscore, underscore, class, underscore, underscore. But as it's pretty complicated to say it in verbose, we call them dunder class. Okay, dunder methods. Dunder stands for double underscore. So dunder class, okay? Dunder class means underscore, underscore, class, underscore, underscore. So if you read lift1 dunder class, here we are. So main lift, which means that Python writes the class you use to instantiate this instance here, directly into the instance. It's very simple. I don't know if unfortunately, but this is a trick. This is very important in Python. If you look at lift1 class, where it is in memory, and lift2 class, where it is in memory, well, look at this. These are the same. This is so important because instances are separated, but the class they come from is the same. And instances are linked with the class at runtime. Keep it there for a second. Let's move into class attributes, and we will see why this is important. I have 50 minutes. I hope I can make it. Classes can have attributes. So if I define this, max weight equal 120, as you can see, there is no self in front of it. It's not self.maxWeight. This is the class. It's just like saying, I don't know, a door has hinges, okay? Or all the doors in my, this is Python, this is a universe in itself. We are like the gods, small gods of this universe. And we say all the lifts in this universe have a max weight 120. No changes, okay? So all the lifts have that. So when I instantiate this class twice in lift1 and lift2, look at this. Well, the class has an attribute. I can read it saying lift1.maxWeight. Fair enough. And lift1 and lift2 as instances have the same attribute. Well, this is expected because somehow, they are lifts. And the important thing is that these attributes are not written into lift1, but they are read directly from lift. Let me show you this. If I say lift1 max weight, sorry. If I say lift as a class, max weight equal 400, remember, I'm God in this little universe, small God, and lowercase. And I can say, suddenly, all the lifts in this universe, they change. They have a max weight of 400. Click, done. Yes, done, because suddenly lift 1 and lift 2 have a max weight of 400. Oh, amazing. That works. What happens, and this is the trick, the tricky part, if I change the max weight in lift 1 in an instance, not in a class? Let's look at it. Lift 1 max weight, 500. Lift 1 max weight is 500. Perfect. That works. But lift 2 max weight is still 400. And this should be lift. There's an error. And the class didn't change. So what happens here? That I can change the value in an instance, and this doesn't affect other instances of the class. But if I change the value in the class, the instances are affected. I need to understand this. What happens behind the scenes? Let's look at this. Let's look at what lift 1 has in itself. I look at Dict, which is a sort of a report of what's inside the object. I have floor, I have status, and I have max weight. Look at lift. Let me have a look at lift 2. Dict. Live coding. Let's see if it works. Okay, amazing. This is what I wanted to show you. Lift 2 has floor, has status, but doesn't have max weight. But I can read it. So how does it work in Python? Very, very simple. There is a mechanism called attribute resolution, which works with this get attributes value function that is transparent. What happens is that when you ask lift 1 to give you max weight, lift 1 says, I have max weight, I have my own max weight. So I give you the value I know. Well, there's also flow, don't worry. This is the mistake I made before. This is the max weight I have. I give it to you. Well, when you go and ask lift 2 says, wait a second, max weight? I don't know anything about max weight. But Python, this is interesting, Python doesn't like to throw errors at you. It's very friendly. So it says, wait a minute, I don't know anything about max weight, but I know who to ask for it. So it goes to the lift class and asks for max weight. And the class says, yeah, I know about max weight. Here it is, 400. So, long story short, sorry for being a bit verbose, instances and classes are connected in Python. Not only instances know where they come from, but they can go to the class and ask for attributes and for methods when they don't have them locally. Okay? I hope this is clear. Let me see if people are getting crazy. Is there a way to know how many instances a class has? I am not sure. I think there might be a way, but yeah, exactly. Rob says you have to implement the behavior into the class, so you have to count them. Yeah, that's possible. Not by default in Python. Okay, let's go on, and then we have the break. Sorry, I'm fast-paced, but yeah. There's also an advanced part here. Read it on your own. It's part of the workshop, but I don't have time to look at it. It's method resolution. It's a bit different from attributes resolution. So the exercises for next 5-6 minutes are: modify the lift class as shown. So copy this, open a new cell and just copy this here. Adding a class attribute status, okay, status with value undefined, this thing here. Now create an instance. What value does the status attribute of the instance have, and why? what happens if you change the value status in the class. Okay, experiment a bit. Try to understand how this thing works. It's a bit more an experimentation than an exercise. And the second one is modify the div class as shown, status closed, but now this time the init doesn't have status. Okay, so initialize it and look at what happens at the status value in the class. Call open. What is the value status in the instance? Explore and try to understand how this connection between between instances and classes behaves, because this is one of the most important things in Python. Believe me, I've been using Python for 20 years. That's paramount. So yeah, enjoy. Let me see if there are questions. Not yet. Okay. Marlene, you're probably listening. If you see people, asking questions and me not paying attention, just ping me and say, wake up. Let's say 5 minutes, then I give you the solutions, and then we have the break, 15 minutes at noon. So Marlene doesn't scold me because I'm running late.
That's fine, Leonardo. I will not scold you. It's okay.
Yeah, I'm just joking. If you are a JavaScript programmer, remember that undefined is nothing in Python. It's just a string. Sorry, it's a bad choice of value. Probably should have said something different, but because I gave this workshop to some JavaScript programmers, they were like, "Oh, this is undefined." No. This is just a string. Okay, foobar, whatever. Cat. Don't worry. Okay, let me give you my solutions, comment them at least, and then we can have the break. What is this? Python 4 instances solutions, yes. Cool. So, okay, this is the new class that I have. That I should run all my sets. Yes, here we go. This is the new class I have. What is the problem here? Obviously, this is something you shouldn't do. Okay, good example there. Well done. You shouldn't do it because this is an example to show you what happens when you have a clash between names. Status is here and status is here. Okay, this is a bad choice. So take it as an example of what you shouldn't do. But let's see what happens and how and why maybe. So I instantiated lift1 open. That's okay. F and S. So suddenly lift1 status is open. Why is it open? Because I passed open, which goes here, which goes here, which goes directly into self status. So when lift1 is asked for status, lift1 has status in its lift1 dict in its dictionary. It's here. So lift1, when you go to lift1 and says, "What's your status?" Lift1 says, "I know about my status. I don't have to ask anybody else, right? Because it's here." And if you change the status in the lift, like let's say disabled, for example, because, you know, again, you are the small god of this universe, you want to disable all the lifts in this universe. But lift1 doesn't care because lift1 knows about the status. So this is ineffective, which is why this example is not a good one, right? It's a good example of what you shouldn't do. So it's a good example of what you shouldn't do. Good negative example. So my point is, as you create a status inside the instance, the same attribute in the class is ignored. Okay, it's pointless. So this might go away. Let's see what happens in exercise 2. Things are a bit different here because I have the attribute status in the class, but I don't have it in the instance. Self status is not here. Okay. So I instantiate it. Obviously, you know, now I can't pass the status because the init prototype, okay, the set of attributes the init wants is different. When I ask for lift1 status, I get closed. Why do I get closed? Because, well, lift1 dict, sorry, doesn't have, sorry, it has it because it's here. Okay, let's forget about this. Sorry. Lift1 status works. Why? Because it goes into the class to have it, to retrieve it. This didn't work. Sorry, because Jupyter Notebook, the cell that I entered here is using the values that I created here. So sorry for that example. Forget what I did with that cell. Forget it. So lift1 status is open. Sorry, let me restart and run everything because I messed it up. Yes, this is what happens when you do things live. Cool. Now we are here. Lift1 is instantiated. Lift1 status is closed. Why? Because lift1 doesn't know anything about the status. And it goes to the class, and the class says, your status is closed. That's it. If I change lift status to disabled, suddenly lift1 becomes disabled because they are still connected. Look at what happens here. However, this is very tricky. Okay, I saw it happening many times in my Python code and in other people's code. Now I call lift1 open because I want to open the lift, right? And lift1 status is open. That's okay. Look at what happens here. Then I change the status in the class, and the status in the lift doesn't change in the instance. Why? Because the instance doesn't have self status. But when I run open, I do this, and this creates the status attribute in the instance. Remember when I first created a floor attribute, you know, with a typo in it? That's what happens. I suddenly create the status attribute in the instance, and now lift1 is disconnected from lift as for status. This is important. So class attributes are useful. You can find them in many Python libraries, but they are tricky. So my point is, and with this I come to an end for this first part. Remember, classes, ideas, instances, concrete, incarnation, sorry, that's a very religious word, but of these ideas. Instances are connected with classes, and they can go there at runtime to retrieve attributes and methods. Remember also, however, that it's tricky to have to use class attributes in methods. If you do this, you are overriding status, and it doesn't work. It doesn't work as expected, probably. So yeah, keep it in mind. Okay, cool. I'm in time. 15 minutes of breaks. See you in at noon 15 for the second part of the workshop. In the meanwhile, if you want to ping me, send me questions, I'm here. Thank you. Great. Cool. So welcome back. I hope you had a good break, ready for, to hear me rambling again for 45 minutes. Okay, let's move on with the second part of the workshop and the second part of object-oriented. So I didn't mention it before. Object-oriented traditionally has 3 pillars, which are named encapsulation, delegation, and polymorphism. And this is my personal, delegation is my personal war against the establishment, because every time you read about object-oriented around on books and articles, posts, or whatever, people mention inheritance as the second pillar. So encapsulation, inheritance, and polymorphism. I disagree with all myself. So it's not inheritance, but it's delegation, which is something a bit broader. I'm gonna show you in a second. So let's talk about delegation. This is my workshop, so we are talking about what I want. Sorry, just joking. Let's talk about specialization first. So what does it mean that I specialize in something? Let's talk about ideas. I have the class animal and the class cat, okay, here. What does it mean that cat specializes the class animal? Well, let's see. First of all, cat has all the features of animal. So, for example, an animal is an animal because it moves, right? And a cat moves. Same feature. Cat can provide new features. So, for example, the cat has whiskers, right? Not all animals have whiskers. For example, a duck is an animal but doesn't have whiskers. So this is a new feature that cat provides. And third, cat performs some of or all the tasks performed by animal in a different way. So the cat moves as any other animal, but it moves silently. Like, I'm pretty sure that an elephant doesn't move very silently. Like, the cat is more silent. So this is the definition of specialization. So cat implements only new or changed features and delegates, here we have delegation, delegates the remaining features to animal, which is why the arrow is in this direction. Cat specializes animal because it delegates to animal what it can't do, okay? There are 2 types, or 2 ways to implement delegation in every object-oriented programming language. So Python, in Scala, in Java, whatever, C++. And the first one is composition. The second one is inheritance. I'm working on this. There are many ways to introduce these things. I don't want to ramble for 1 hour, so I will try to be a bit compact in my explanation. I associate composition with the verb to have. So when you think about a car, as in the example here, the car has an engine and has wheels, and probably something more. If it's a good car, it should have other things, but let's give this as a simple example. The car has an engine. The car doesn't, the car isn't the engine. Okay, it's not just the engine. It's a composition of parts that you can isolate. You can open the bonnet and extract the engine and go around with your engine, just the engine, right? So the car is composed by the engine, by the wheels, by blah, blah, blah. And the car can delegate to the engine, because when you say start the car, okay, you go into the car, you start it. Well, actually, you're starting the engine. You are not starting the car, but, you know, by extension, this is delegation. Car delegates to the engine. The second type of delegation is inheritance, and you might know this a bit better than composition. What is inheritance? Inheritance is connected with the verb to be, because you see, the cat is an animal. You can't say the cat has an animal. Yeah, I mean, where? If you dissect the cat, you shouldn't. But if you do it, there is no animal part in it. You know, like say, oh, this is the cat, this side, and this is the animal part of the cat. No, it doesn't work. Animal is part of the whole thing. It is an animal. Okay, does it make sense? I hope so. Again, it can delegate, because when I ask the cat to meow, it's the cat that meows, right? While the move comes from its animal nature. I hope this makes sense. So composition, inheritance. Okay, composition is something you can do in every single object-oriented language, and you don't need any support by the language, while inheritance goes by the rules set by the language. I'm not talking about composition too much today, because I don't have the time, and it's a pity, because composition is important. And so my advice before I go on, my hint is, please don't forget composition. There is a mantra which is composition over inheritance. Not because composition is more important than inheritance, they are both equally powerful, but people tend to use inheritance everywhere, and this is problematic. I'm not saying more than this. Or we can hang out, you know, and chat a bit about this. When you design some software, think about composition, learn to use it. That's it. Let's go into inheritance. How do we implement inheritance in Python? You might know this, but yeah, indulge me. So I have here my class lift, as I had before, with the max weight as well as a class attribute. And I can create this other class, security lift, and specify lift here. This syntax means that security lift inherits from lift. It specializes lift. Okay? As you can see, security lift is empty. Let's see how it works. Let me run this. As always, it goes to the bottom. Sorry. Where were we? Okay, here. So I have lift and I have security lift that specializes lift. I can instantiate security lift. And this already tells you something, because I'm using security lift as I used lift, giving the same thing, basically using the same init method. And there is no init method here. So hints that there is some connection between the two, right? Remember the delegation concept. As lift has max weight, which is, this. As lift max weight is security lift max weight. Okay, so let's look at this. Is in Python doesn't mean it has the same value. Okay, is means it is the same thing. Exactly the very same thing in memory. Okay, keep it in mind. Different. It's not equal. It's different. So when I say slift as an instance is max weight is a security lift, I'm saying that the instance and the class have a connection. We already know this. We saw it in the previous part. So slift doesn't have the max weight. It goes to the class. Easy peasy, right? So they are the same. But there is something more that we can discover, that security lift max weight is lift max weight. And now we are talking about two classes. This is an instance and this is a class. And we know there is a connection between the two. But this is a class and this is another class. So we discovered something interesting here. How does delegation work? How does inheritance work in Python? There is a connection between this class and this class. The same connection that we had before, between the instance and the class. We had the same connection between the class and the superclass. Okay, this is called the superclass. This is called the child class. There's an inheritance between the two. Okay, let's look at behind the scenes. This is a workshop about behind the scenes. Okay, so let's look at what happens inside Python. slift dunder-dict. What does slift have? Slift is an instance of this. I instantiated it giving one enclosed, so I created the floor and status, and this is what I find into slift. Not different from what I found into lift1 and lift2 in the previous part. Let's look into security lift as a class. It's surprisingly empty. There are a couple of things here, dunder module, dunder doc. I'm not interesting about them. They are not very important in this context. It's pretty empty. You know, where is max weight? Where is open? Where is closed? There is nothing. Yeah, there is nothing because the class is empty. Everything is in lift as it was before. So, question, where is the connection between security lift and lift? We know that the connection between slift and security lift, or between lift1 and lift before, it's into dunder class, right? If you type that, you get the connection. The connection between a class and a superclass is into basis, dunder basis. Okay, same thing. Python is really straightforward on this. It just writes into the class, the superclass. You may notice this is a tuple because Python allows you to use multiple inheritance. It's amazing. It's really, really dangerous and complicated. No, it's not really complicated, but it's a double-edged sword. So I'm not talking about multiple inheritance. I have some posts on my blog if you want to read them. Not for now. Just think about single inheritance, single class inheritance. What can you do when you inherit? Remember, delegation. You implement only the new or the changed features. So what you can do is to re-implement or override the methods. So if you say def open in security lift, then suddenly you can use this in slift instead of the one that you defined in lift. Same thing that happens between instance and class again. So there's a delegation. You asked for slift open. Slift as an instance says, I don't know anything about open. Let me ask my superclass, right? My class, sorry. It goes to security lift and it says, do you know anything about open? And security lift says, yes, sure, I have my method open. I don't have to ask anybody else. Well, if you use close, security lift itself says, I don't know anything about close. Let me ask my superclass, maybe, okay, delegation. By the way, I'm just mentioning it, instead of, so what you can do when you override a method is to use super. Super is automatically giving you the superclass. So you can use it to avoid re-implementing code. I'm going very quickly on this because I want to go to the exercises. I have time. The point here is, look at this, self-status equal open. If I go to the lift class here, look at this, same code here and here. Now, if I have an advice for young programmers is that duplicated code is evil. Okay. Sometimes it's worth having duplicated code. I'm not saying that you should be OCD about it, but yes, a bit you should be OCD. So what happens with duplicated code? In this case, come on, this is just an example. Okay, self-status open. There shouldn't be any bug in this line, because it's very simple. But think about it, if this was a very complicated algorithm, right, that you are implementing, you have the algorithm here and you have the algorithm even here, same code. If you discover a bug, chances are that you solve the bug in only one of the 2 or 3 duplications. And this shouldn't happen, because suddenly you have something that works sometimes and it doesn't work other times. So my point here is duplicated code should be avoided unless you exactly know what you are doing. Okay, and the case is very simple. So to avoid duplicating this code, long story short, what I do instead of duplicating it, I call the code that my superclass provides. In Python, you can use super. The call for the code of the superclass is not automatic. Python doesn't do it at all. If you override it, Python doesn't know anything about the superclass. You have to do it explicitly. And you can do it before doing other things, after doing other things, in the meanwhile. It's up to you. You have to decide when to do it. Okay, enough. Let's discuss a bit about composition. I'm going to show you probably not a bad example. I'm going to show you the limitations of composition. Again, I don't have time to show you the virtues, because there are many, but they come into play in more complicated cases. So just let me show you what happens with composition. This is a composed class. So security lift is not inheriting from lift. It has a lift inside it, like the engine for the car, right? So this is not a good example for a security lift, doesn't have another lift, but yeah, think theoretically now. It has an instance of the other class inside. So you can instantiate it, and this works because init is delegating explicitly to the init of the lift. It works. But as soon as you try to read the floor attribute, it doesn't work. Why? Because security lift doesn't have it. And there is no automatic delegation, because the automatic delegation comes from inheritance, not from composition. In composition, you have to implement everything on your own. So, for example, here, I might want to create this, which is a property. I hope you know how to use properties. These are methods that behave like attributes, or attributes, yeah, methods that behave like attributes. So this method floor gets called whenever I run self-flift.floor. And what I'm doing here, look at this. This is an explicit delegation. I'm returning self-lift floor. I have to do it. And I have to do it for status. And I have to do it with open. So at this point, you might think, you know, the composition is terrible because I have to do it. I have to do everything on my own, right? Two, you have to do everything. But this is a bad example, because in this case, a security lift is a lift. So this is a good case for inheritance. But think about the car and the engine. What do you have to delegate from the car to the engine? Maybe just a method, just the start method. And you have to write something like this: def start self.engine.start. And that's it. And you delegated the part that you need to delegate. So my point here is I don't have the time to give you a proper example of composition. Probably I might rework a bit the workshop, but yeah. Again, and then I stop rambling, I promise. Don't forget composition, because it's very, very powerful. If you say the car is an engine, then suddenly you have all the problems of dealing with the fact that the car doesn't want to expose methods that belong to the engine, because the car isn't an engine. Okay? So you spend a lot as soon as you spend time trying to avoid your class using methods of the superclass because you don't want them, chances are that you are using inheritance instead in lieu of composition. Okay, just that's it. Okay, as well. I stop rambling about these things, but keep it in mind. Let's go into exercises. Where are we? Delegation inheritance exercises. As I said, exercises about inheritance, not about composition, because probably we don't have the time. Cool. The exercises are the following. starting with lift and security lift. So go and grab, sorry, I should have copied them. Go and grab the lift and security lift that I have here. So these two, okay. Starting with those, modify security lift, adding a custom init method that creates the attribute self-locked. So you have to go here and write here def init self fs and then do something to create the attribute locked. Okay, try to do it. The exercise 2 is go on with what you did, change the security lift method open to work, so define it and make it work with self-locked. So the idea is what we started with at the very beginning of the workshop, you know, that security lift should be opened only if it's not locked. So there should be a difference, because as for the lift, you have this just gets open, right? Instead, the security lift should say if it's locked, oh, if it's not locked, open, otherwise stay closed. And exercise 3, go on again, change the security lift method close to accept an optional parameter lock that sets the locked attribute. Okay, this should be like this. Cool. So enjoy the exercises. I'm checking questions now and then coming back for the solutions. Okay, sorry, I was answering some of the questions. I finally managed to look at the chat and at the screen at the same time. Let me discuss a solution for these exercises. Where are we? 5 delegation inheritance solutions, yes. And there was an interesting discussion here, I believe, about what I said about object-oriented functional in the chat. These are I don't have final answers to these things because they are very interesting. Just to say, follow a bit the discussion there and get in touch. I mean, I'm so happy to discuss about these things. In general, my approach is I like the theoretical part of languages, but in the end, we have to bring home the bacon, as we say in UK. Like we have to get the job done, and we should aim to have the job done, not trying to mess up everything. Okay, we should try to do things the proper way. This is why I tend to discuss about the internals of the language, understanding what the language can do, understanding what it can't do. I'm not against changing the language, for example, right? If we can, well, okay, enough. Inheritance exercises. Exercise 1 said start with lift that we have here and security lift. And adding a custom dunder init is just a matter of adding it here with some code, okay? So what is the, thank you, David, I'm gonna answer you later. So there are several ways to solve this exercise. So I have four different solutions. So let me comment them. First solution, I read, literally this says init method that creates the attribute self-locked. That's it. And I do exactly what it says. So init method creates the self-locked attribute with a value, for example, false. Okay, I don't accept it here. I just create it. Fine, that might be a better solution. Let me go on slowly. So the first thing I notice about this method is that there is duplicated code. So self-floor equal F, self-status equal S is the same code that I have here. Again, just to be crystal clear, this example is very simple. In this case, I wouldn't argue, okay? I wouldn't code review this code saying, what are you doing? Duplicating code, you're evil programmer, right? No. That's perfectly okay. I mean, that's very simple. But in general, I use a simple example to signify something bigger, right? And I saw bigger systems. I saw big functions and big algorithms. So this is why I insist on code duplication. In this case, it might be not that dangerous, okay? But if I want to get rid of this duplication, I can do it with super. So I can call the init of my super class. So super init of F and S, okay? This calls this function here and initializes floor and status. Okay, the point is I'm just creating the locked attribute without passing a value. So I might add it here. I can add L and say self-locked is L. So now when I instantiate security lift, I can pass false or true, right? This works, but has a limitation, which is what I say here. I am changing the interface of the method, of the class, sorry, the prototype. What do I mean with interface? Let's go back to what I said at the very beginning of the workshop. Behavioral meaning is important, right? So here we say that security lift is a lift. Okay, so I expect security lift, externally speaking, behaviorally speaking, to behave, sorry. Yeah, I expect it to behave like a lift. This is what I mean. For example, if I say, oh, you know, this is a lift, but it doesn't have a button, it doesn't have a door, it doesn't go up and down. Yeah, so it's not a lift, okay, because it doesn't behave like a lift. So here I am changing the prototype. So suddenly, if I want to instantiate this, I have to say security lift, and then I have to give the floor, the status, and the locked. I can't initialize it as a lift anymore. So I can leverage default values because I want to augment my method, not to change it completely. Does it make sense? I hope so. If not, ping me in the chat. So I am basically saying my security lift can also be locked. But if you don't want to lock it, you can just use it as a lift, right? And nothing changes. Great. So this is my final. This will be my final solution. This is probably what I believe is the best solution for the exercise, depending on the requirements, however. And the exercise 2 is change the security lift. So this that I came up with, adding the method open to work with self-locked. So you can open it only if it's not locked. So that's just a matter of adding this. Okay, open. Overrides lift open. So now security lift has its own open method. And what I do is just saying, if not self-locked, self-status open. Okay, so this is what, if you go and check what I have in my very first notebook about object-oriented, this is where we started, right? We started from, can we, you know, connect data and methods, and we did it. Now we also have a way to connect them and reuse what we already wrote. And speaking of reuse, I see code repetition here. Yes, I am OCD about code repetition and code duplication. But yeah, again, it's an example. Self-status open is exactly what I have in open. So I might say, okay, open, security lift open wants to do exactly what lift open does, but only in the case it's not locked. As you can see, as I told you before, Python doesn't call the super method automatically. This doesn't happen in Python. Okay, it's up to you to decide if you want to call it and when you want to call it. So in this case, I call it conditionally. Okay. Exercise number 3. Oh yes, I thought this was shared by on the conference website. I'm gonna share it in the chat in a second. What was I saying? Yes, exercise number 3. Change the security lift method close to accept an optional parameter lock that sets the locked attribute. So when you close the security lift, you also want to lock it. Okay, don't know if it makes sense in real life, but this is what happens in my code. So this is just a matter of defining the close method. But as you can see, if I want to accept this parameter, I have to make it optional. Why? No, wait, sorry. I don't have to, I want to. Because if I just say lock, if I remove this part, this changes the prototype. This changes the interface of my method. So suddenly security lift can't be used as a lift anymore. This is important for the next part, by the way, but we'll discuss about it. So lock equal false. So now close can be just called as close, or close lock equals something. I again try to avoid code repetitions. So I call what the close of my super class does, and then I lock it. Quickly about what I was saying, that Python doesn't call the super automatically. So here I have to decide if and where to call it. In this case, I might do this. This works, it's exactly the same, because I just set locked and then I close it, or I close it and then set locked. I don't care. In other cases, however, you can't do this. Okay, you have to decide if you want to first call super and then act, if you want to first act and then call super, or if you want to, do something, call super and then do something else. It's up to you. So this is part of the design. Yeah, since I have 5 minutes, let me ramble a bit about this, and then we can have the break. Working with languages, working with a functional programming language or working with object-oriented programming languages, is not about writing code, or not just about that. And please get away, get out of this mentality. A lot of people say, oh, I'm a coder, I produce code, right? No, wait. That's okay. That's what we do, practically speaking. But the most important thing we do is to design software. We are designers. I have a talk on Friday. You are kindly invited to join me about clean architecture in this conference. It's about design. So when you write your code, you have to think if you want to use inheritance or composition, to think if it's worth creating another class, to think if it's worth duplicating code or not. And you have to design, and this is particularly important. This is paramount in object-oriented programming languages, because what you have, object-oriented programming languages are all about, this is interesting. This is exactly what the creator of Smalltalk, one of the creators of Smalltalk, said about it. Smalltalk is one of the languages Python comes from. He said the initial idea of object-oriented was to create a computer in a computer. So an object is a mini computer. It has data, memory, and methods, like a CPU that does things. And you have many objects in your software that interact, they collaborate. And this requires design, because if you don't design it, it's a mess. How many times you end with a mess? A mess of methods that are in the wrong objects, a mess of objects inheriting from objects they shouldn't inherit from, and then you are like, oh, why? I should have used composition. I told you. So this is what I mean. And then now I stop rambling, but this is important. You have to design your software. You have to think about it. And this is why I believe a perfect companion to the object-oriented programming is the TDD methodology, so testing. TDD allows you at any time to redesign your application, to stop and think, as I like to say, stop and think, is what I'm doing correct? Or can I try something different? Can I try to reorganize everything, and come up with a better solution that does the same, refactoring. Does the same. It's the behavior, meaning. The important part is the behavior, meaning. You see, this repeats itself at a larger scale. I stop rambling. Sorry, I'm chatting too much. It's time. Let me see. There's a question. There are 3 minutes. So, what does the super calling the close function does? Oh, sorry. Okay, Joseph, I'm answering now. So, what does it do? I want to close the security lift. So what I want to do is to say, so let me write it properly. I would say self.closed, no, come on. Self status equal closed. This is what I would do. Because this is what closing the lift means, right? Setting the status to closed. And then since this is a security lift, I'm also setting the locked. Okay? So this is exactly the same thing that happened here. Self status open, and then I replace it with super open, because this is perfectly fine. Okay? This works. Done. Job done. But then the OCD programmer, comes in and says, yeah, you know what, self-status equal closed is exactly what you have here. Come on, it's the same thing. Why are you duplicating code, you bad programmer, right? You are evil, the source of evil in the world. So this is why I go here, and I'm joking about the evil in the word. I just say close, and this is the way I avoid the repetition of the code. Joseph, is it clear? Yeah, there's some lag, so probably he will answer in a second. Okay, it's time for a break. So we'll see you later. Thank you, Kojo. He just shared the repository. See you in 50 minutes for the polymorphism. Ping me in the chat if you have questions. Thank you. Great. Hi, everybody. Welcome back for the third and final part of the workshop. We are on time. We're doing well, so I swear I will finish for 2 p.m. That will be right in time. I was looking at this interesting article that Rob shared on the chat. Thank you, Rob. It's very interesting. It's a bit outside the scope of this workshop, but it discusses default arguments and immutability. That's very interesting. It also shows you something that will happen in Python probably with PEP, non-aware operators. It was very interesting. Read it. And actually, reminded me that I had the very same problem exactly this day. So the day before, actually. And this is the article that I wrote on my blog exactly to expose that bug. So that's interesting, because when you read things and you think, oh, this happened to me so many times, so dangerous. Okay, enough rambling about my bugs. Let's talk about polymorphism. It's the third pillar in object-oriented. So again, sorry. We have encapsulation. We put data and functions together in classes, in objects. We have delegation. I hopefully convinced you that it's not just inheritance. However, that's that thing, the connection between classes. And now we have polymorphism. Polymorphism comes, the word polymorphic comes from Greek, and it means it has many shapes. Okay, polymorphic. What does have many shapes? Let's look at this. Let's start discussing Python's type system, because we are talking about type basically. Okay, this workshop is about type. What is the type system in Python? Well, we saw something at the very beginning, that I, coming from C and coming from languages, assembly and C, low-level languages, found very surprising at the very beginning. I'm talking about 20 years ago now. Yes, I'm going to answer you later. Sorry, I was checking the chat. What I found surprising was this. If in Python I write a = 5, let me run all this says. Every time I forget to do it. Yes, thank you. Okay, so if I say a = 5, well, this works. Type of a is int. The a has a place in memory. Okay, it's a very low place, by the way. This is a fun fact about Python. The numbers are pre-allocated in Python, so some of the integers, because they're used a lot. Okay, so this is a very low region in memory. But then when you write, this is a fun fact, doesn't have anything to do with polymorphism. Then when you write a = 5 as in a string, right? Again, it works. Type of a is a string now, and the ID is different. And this surprised me. It might not surprise you, but it surprised the C programmer that I was, still am. It's like, how comes a changes nature? A is a variable, contains an integer. Why does it suddenly contain a string? Why does it change the type? So what I discovered, yes, I discovered it, but this is public domain, right? It's not that I invented anything. Python type system is strong and dynamic. What does it mean? A strong type system means that every variable has a type. So if a equals 5 and b equals text, then type of a is int and type of b is string. This is not true, for example, in, I don't know, Bash. Bash, as in the terminal, like the shell, that has a programming language, and everything in Bash is basically a string, okay? So there is an initial concept of types, but there are no real types. So in Python, as in JavaScript, as in many other languages, everything has a type. This is strong. It's dynamic, however, because the type of variables changes with the content. So in Python, you say a equals 5, then suddenly the type of a is int. If you say a equals text, then the type of a changes. Okay, so variables are not immutable boxes. This is what I mean. Immutable as in the type they contain. This is true in C. In C, you say int a, and you say a is a variable of type int. That's it. If you can't put a string in it. In Python, you can. So what does it mean, all these for Python, for you as a Python programmer? That in Python, you can run something like this, which is a very simple function that just returns the input. And it's incredibly powerful, incredibly simple, but incredibly powerful. Because if you think about it, this function returns whatever you give to it, whatever. If a is an integer, it returns the integer. If it's a string, it returns a string. If you give this a database connection, it returns a database connection. That doesn't mean anything for Python. It just says this is an object. This is why in Python we say, well, we express this in Python saying everything is an object. And Python is just concerned with one type, object. This is interesting, but why does it have with polymorphism? Well, first of all, because polymorphism, many shapes. And you can see that here, A can have many shapes. It can have the shape of an integer, can have the shape of a string, can have a shape of a dictionary, whatever else. And it works, okay? This is an initial hint of what is going on. Let's look in detail at polymorphism. Let's do this. So if I write 5 plus 6, it works, okay? 11, great. We know that Python works as a calculator. We can also sum floats. With the same operator, plus, we can sum strings, which was surprising when I first started using Python. It was like, oh, finally, a language that can, merge strings easily. It works with lists and with tuples, but it doesn't work with dictionaries. That's interesting, because plus is polymorphic. It has many shapes. Here, it's an addition between integers. Here is an addition between floats. And you might think, okay, these are just numbers. It's the same thing, right? Yeah, but this works with strings and lists. All these additions have a different meaning. I mean, it's addition. What does it mean, to add strings? And actually, it doesn't work with dictionaries because the addition between dictionaries is not defined. We can define it, okay? Well, it's not defined by default in Python because the idea is, what happens if I have the key C here and I have the key C here? What's the final result? Not defined. Okay, so it doesn't work. So it's polymorphic, but not for every type. Okay, let's go on. Let's look at len. Len of just a sentence. It works. It gives me the length of this string. It works with lists. And it works with dictionaries this time. Oh, finally, something that works with dictionaries as well. It counts the keys or the values as the same number. Unfortunately, it doesn't work with integers. Why? Because integers don't have a length. Okay, so what is the length of 123? though, don't know, not defined. And it's interesting what Python says here, because this was a hint for me to understand what was going on behind the scenes. Object of type int has no len. And I thought at the time, well, wait a minute. I didn't ask for len of the object. I asked for len of the object. You know, like sorry, I said the same thing. I didn't run the function that belongs to the object. I just run a function on the object. But yeah, this is what Python says. So what's going on behind the scenes? Going a bit further into the polymorphism. What happens is that len of s as a string works because s as a string has a dunder len method. So when you say len of this goes into the just a sentence object and runs automatically this dunder len method. The same for lists, the same for dictionaries. Why doesn't it work for integers? Because integers don't have the dunder len method. So let's recap a bit before we give the final solution, how polymorphism works. When you run something like this, and when you run something like this, there's something that Python does using the methods of the objects, as in len of just a sentence is len of belongs to the object. Okay, let's look at this. Polymorphism is based on delegation. Okay, so when I run 1, 2, 3 as a list dot dunder add 4, 5, 6, I am using a method. You know this, right? You are delegating to the list the addition. But this is exactly what happens when you do. I should have written here. This is what happens when you do this. 4, 5, 6. This plus delegates the addition to 1, 2, 3. The plus doesn't know anything. Basically, plus is not implemented in Python. There is no code in the Python code base that says plus does this with integers, plus does this with dictionaries. Not at all. Integers know how to be summed. Lists know how to be summed, okay, or added. I hope this is clear. Look at this, dir of 1, 2, 3. Look at what we have inside a list. Add, then we have eq, which is what Python calls when you do equal equal. We have ge, which is what Python calls when you use the greater than, and so on and so forth. Mul for the multiplication, many things, okay? Plus all the methods that you already know. So when, for example, you say 1 in 1, 2, 3, this is something you can do in Python, right? And well, it works, right? It gives you true. What happens behind the scenes? That's Python delegates this to the list, saying 1, 2, 3, dunder contains of 1, which gives you true. One thing that I have to say about Python, I like the language so much. I'm a Python programmer. I've been using it for 20 years. It's so amazing. But there is one thing I don't like, but a couple. But one thing in particular, there is no direct connection, between operators like len, plus, in, and the method, the dunder method used for them. So for example, len goes into dunder len. So you think, okay, makes sense, right? Len, dunder len, great. But plus goes into dunder add. She's like, okay, plus add makes some sense, okay? In goes in contains, which is like, okay, really? In Scala, for example, I'm a big fan of Scala. It's a great language. Probably the best match between functional and object-oriented programming that I saw in my life is amazing. In Scala, you have that plus maps to the method called plus. Plus as in the symbol, you know. So Yeah, just to mention, I wanted to ramble a bit about Python probably against. There is no connection between these two things. So expect when you implement operators, you have to go and check the documentation to discover, what is GT, what is GA, what is EQ, MAL, all these things. Okay, so keep it in mind. Okay, enough about that. I'm going to show you something, and then we have a lot of exercises for polymorphism because this part of the lesson is partly really the exercises. Polymorphism in action. Why is it useful to have a polymorphic language like Python? I want to create an infinite number container. What is an infinite number container? I can do this, right? 1 in 1, 2, 3, and it's 2. But if I say 4 is in 1, 2, 3, it doesn't work because 4 is not in 1, 2, 3. 1, 2, 3. I want to create a container that contains an infinite number of numbers. Let's see how I can do this. I define a class, number container. I define an init. It's just a matter of saying, for example, an infinite container of even or odd numbers, for example, right? So I just have a flag here. Even just sets a flag. That's it. Then I define dunder contains. The dunder contains is linked with in, right? What does dunder contains do? If self-even is 2, this is going to return if the element that I am considering is 2. So this is basically a way to say, is element even or odd? But look at what happens. I hope this is clear. Look at what happens if I use it. So I define this. I instantiate it. Even is number container. Even is 2 by default. 2 in even. Yes, 2 is in even because 2 goes here, contains, and then it says if self-even, so like 2 is, it returns, self-even is 2. It returns 2 divided by 2 equals 0. That's 2. So 2 is even. 1, 2, 3, 1, 2, 4 is even. This number that I'm not going to read it is even. Yes, this is my infinite number containers. Do you see what I realized? I realized something in Python that contains all the even numbers, even though it doesn't really contain them. Okay, this is polymorphism. This behaves like a container, but it doesn't contain them for real. Okay, so obviously this works with odd numbers. They are not contained. I can define the odd container, and 5 is in odd. Okay, it's the same thing. But what I wanted to point out before we move to the exercises is remember what I said at the very beginning. The behavioral meaning is important. So this number container it is a container, but internally the structure of this thing is not a container because the numbers are not there. There's just a logic. But the behavior is important. And whenever I need something that contains all the numbers, I have it. Okay? I hope this must make sense. I'm going to say something about behavioral meaning at the very end. For the time being, let's move to the exercises. I have a lot of them, so we have half an hour. I'm going to split it into sessions. Maybe we can just discuss about the last exercises. I don't know. So the first exercises are, as I said, there are many. First exercises are, number 1, create a class custom integer. So just create it, don't inherit from anything, just a class that contains an integer as a self-value, and with a dunderlen method that returns the number of digits of the integer. So what I mean is 5 has 1 digit. So 12 has 2 digits. 123 has 3 digits. Okay, so len of this thing should return the number of digits. Does len, not dunderlen, but len, work for instances of the class? Okay, there's a hint here. Convert the integer into a string. Try to do it. But my point is, I told you there is no definition for the length of an integer, right? We said it before. I want to define an integer that has a length. So this is what I want you to do, to try and do. Exercise number 2, add a dunder contains method to custom integer that returns true if self value contains the given digit. Does in work for this type? Yes, Kojo, that's the blog post I wrote. It's a series of 6 posts, by the way. Exercise number 3, try to use string, str actually, sorry, as a function on an instance of custom integer, like string of C. What happens? How can you return a better string representation, for example, showing the actual value? So try to do these 3 exercises. I'll give you like 5 minutes and then I'm gonna comment these, then go on chatting a bit about the following exercises and then, you know, wrapping up. Enjoy the exercises. It's too long. So I was asked about encapsulation. So while you think about the exercises, it was too long to write it, so I just say it. So encapsulation is, again, these. You put data and functions together. So at the very beginning of the workshop, I show you something which is like, you have a data like a lift, and you have a function that opens that lift. And then you have another data, type of data, which is a security lift. It's slightly different. And you have to create another function that you call security lift open or open security lift. And you have to remember the connection between the two. In object-oriented, what we do is to put data and functions together. So objects, as classes and instances, are both data and functions. So an object, like a lift that we are discussing here, or the custom integer that you are creating, contains a status, a state. So data, right? Some data. A string, an integer, a dictionary, whatever. And contains the functions that work on those values. And this is revolutionary. I mean, it's not anymore in 2020, right? But it was 40 years ago. Because at the time, people were used to say, I have a function add that adds to integers, and then I have a function add float that adds to floats. While now we have the integer type and the float type, they can support the addition. So this is encapsulation. Encapsulate means to put together, okay, capsule. As for getters and setters, there are common names for the idea that when you have an object that has data, you want to get that data, so read it, and write it. So what you want to do sometimes is to change the way you read and the way you write. So for example, the object inside has the number 4, but when you read it, you want to get a different number, like 4 times 2. And this is a getter, because you say, I want to get the value through a function. You can do it with properties in Python. So if you don't know about properties, go and check these properties. Setters are the same thing. So when I write something, I might want to write it in a different format. Like, for example, let's say I have something, a string that I just set, but I want to write it in Unicode or in, well, this is by default in Python 3, but I want to write it in a different encoding. Or I have a number and I want to write it as a multiplication between two prime numbers, like all these things. So you want to set it through a function. These are getters and setters. I hope it's clear. As for the exercises, sorry, I chatted the whole time. Let me give you my solution, and then I can go on with the rest. No, this is not the right one. This is the right one. Okay, so exercise 1 was create a class custom integer that contains an integer as a self value. So this is my custom integer class. It just contains a value. As you see here, I said contains an integer self value, but it's polymorphic. So this accepts anything. So if you pass it a dictionary, this works. This doesn't work, but this works. Okay, so we say that custom integer is polymorphic on init because it accepts everything, anything. And with a len method, dunder len method, that returns the number of digits of the integer. So let's see what happens here. Dunder len returns something a bit complicated. Okay, so I have the value that I stored. I transform it into a string, and then I get the len. Let me show you the example so we can easily understand what's going on. So this is C is an instance of custom integer, and this is the integer I have, 1357. This becomes value, and this becomes self value. So if I go here and I say C dot value, here we go. Okay, so this is it. When I run len of C, what happens is that Python actually runs c.len. Okay, this is what happens. And dunder len does the following: converts the value in a string. So this becomes the string 1357. Okay, the string 1357. And it gives me the length of that, which is 4. So suddenly, what do I have? I have an integer that has a len, where I defined the len of the integer as the number of digits. And I provided support for len just by adding this dunder len. If dunder len is not here, custom integer doesn't work with len. Okay? This is a very simple example, but this happens all the time in Python, in many libraries. I agree with David, who says it's quite complicated. I know. I don't have the time to, I don't want to bore you to death and to keep you all the time, all the day, discussing these things. This is complicated. You have to study it. You have to dig into it. I want to give you a glimpse, at least, of what's going on in Python. So apologies if it's a bit too complicated. It's a sort of a start of the journey. Add dunder contains method to custom integer that returns true if self value contains the given digit. So, okay, I add contains, and I say, well, this is very simple. String of digit is in string of self value. That's good, I believe. It's a way to say that that digit is in that string. But suddenly, look at what happens. That if I say 5 in C, it works. It says true. Why? Because 5 goes here, digit. It becomes a string, the string 5 as a character. And the character 5 is in the string 1357. So it's true. While 8 is not in 1357. But look at this. This is not actually checking if the number 5 is in the number 1357. I changed the meaning of the whole thing, and I said, for my class, I define in as that digit is among the digits of my integer. It's in delegates to your class, so the meaning of in changes according to what you define. This is extremely powerful in Python because all the things like len, for loops, in, equal, greater than, less than, all these things, they depend on what your class implements, not on what Python decides. Okay, I hope if you go home with this in mind, that's amazing. I made it my day. Okay, it made my day. Exercise 3, just to show you further this, try to use str, okay, on instance. So what happens if I use str? This is a way in Python to provide a string representation of anything. And the standard representation that Python gives you is angle braces, the name, the class of the object, and then the position in memory, okay? Okay, fine, it's not really useful because I might want to see something more. I want to see the value of C, maybe to, just to tell them, to tell C from the, I don't know, I want to see the value. So I add this, then the str, sorry, I add then the str, and I say super str, which is the standard thing that Python does, plus as in, another string that contains the value. Look at what happens. C custom integer, and then when I run string of C, str of C, I get this, which contains this part, which is the one that I added. So as you can see, this is what I wanted to show you. I am changing the behavior of Python. Python is not as powerful as Lisp. If you want to see a language that is really, really incredibly powerful, learn Lisp. I believe it's worth learning Lisp because it gives you a completely different perspective on programming that Python, JavaScript, or Rust, or whatever doesn't. Okay, so Lisp is completely different. It's interesting for you. Maybe not useful for your job, I don't know, but it's useful for your career, for your mindset. Okay. In Lisp, you can basically change everything. The language is defined in the language itself. it's mind-blowing. But in Python, you can do something very, no, maybe not the same, but very similar. So you can change the behavior of the language according to what you define in your classes. That's it. Go home with this. And since we have 10 minutes, I'm going to run through the exercises 4 to 9 a bit and showing you something. You are free to revisit the workshop whenever you want, so that you have the code, so feel free to go and try to do the exercises, okay? I want to show you what the point of the exercises is. So here, the exercise asks you to define the class shapes list, which is this one. It's just a class that contains an attribute, sorry, I do it all the time, contains an attribute shapes, which is a list of something. It has an add method that adds whatever you pass to it to this list. Okay, so far so good, but it's just a list. And then an areas method that runs this. It runs the method area for each shape of each object in this list. Okay, so up to here, it's just a list. This defines something a bit more advanced. It says, let's run this method for each thing in the list. Now define two classes, triangle and rectangle, that represents a shape. Don't use inheritance. They both should accept base and height as initialization parameters. So let's look at them. Class triangle has an init with a base and a height, self-base, have height, nothing complicated here, and an area method, because this is asked by the exercise. So the area method returns the area of the triangles, which is self-base times self-height divided by 2, if I remember my geometry well. Then I create a rectangle. I don't use inheritance. I create something which is basically the same. Okay, duplication here all the way. Don't worry. It's basically the same, but the area is different. Obviously, it's not divided by 2, right? Cool. And the exercise number 5 said instantiate shapes list, triangle and rectangle. Add the shapes through the add method, and then run the areas. So look at this. I instantiate the shapes list. It doesn't require any attribute here, any parameter, sorry. Then I instantiate the triangle, base and height, the rectangle, base and height, and then I add the triangle and the rectangle to the shape list. So now the shapes list inside its shapes internal list or attribute has these two instances, T and R. If I print T.area, it gives me 10. If I print R.area, it gives me 300. Okay, these are the areas of the single shapes. And when I run SL shapes list dot areas, I get the same values because the function here is just running shape area for every shape in shapes. So far, I hope so good. That's nothing complicated. The interesting part here is that this shapes list is a list of things. We don't specify what. The only attribute these shapes should have is to have an area method. I don't say anything about them. I don't say they have to inherit from the same class. I don't say they have to have a base and a height. This is just because actually triangle and rectangle have a base and a height, but the only thing they have to do is area. So you see, this is polymorphism, because I'm not saying you have to give me shapes or you have to give me triangles. I'm saying you have to give me something that has the area method. Again, behavior. It has to behave a certain way. I hope it makes some sense. Let's go on, and then we can wrap it up. Specialize triangle or rectangle, creating a colored rectangle. Okay, I'm going to skip this. If you, just quickly, if you create color rectangle, you inherit from rectangle this works into the shapes list. Try it, okay? Because I'm passing something that has the same interface, area, the area method. The interesting thing that I wanted to show you, and then I really swear I'm going to stop rambling, define a class circle that requires only single initialization parameter, okay? So only a single initialization parameter. So circle doesn't have base and height, it has only the radius. So it's different, okay? Circle is different. It's not like a triangle or rectangle. It's a shape, but it's different. But since it has the area method that I can, I can do this, fine, this is base geometry, right? As long as this area method works, you can add the circle to the shapes list and you can run the areas method, and that works. I gave you this example because I wanted to show you that this is polymorphism. Triangle, rectangle, you might argue, well, come on, triangles and rectangles are similar somehow, base and height, okay, fine. Let's throw a circle on the table, which is completely different. But since it has the area method, that's good, because this is what my shapes list object wants. There are two exercises here that are interesting because they change the shapes list in order to accept classes and not instances. I'm not going to show you them this code now because it's a bit too complicated. We don't have time. Go and read try to solve the exercise and then read my solution. You have the code. Okay, so 4 minutes to wrap it up. Cool. So first of all, thank you for the patience. 3 hours, it's a long time. What did we discover? First of all, what object-oriented is and why we do it. Again, I'm not saying object-oriented is better than functional, but functional programming is a completely different paradigm. They can be mixed. Scala, for example, Python mixes them a bit, but they are different. Okay, and object-oriented has an idea behind it, which is that of the data and methods together, or if you want, the mini computers working together. Nikki, I'm going to answer you in a second. Second thing, what was it? Delegation, yeah. We can reuse code. As someone said, Kojo said, I believe, you want to achieve the dry, like don't repeat yourself. So you don't want to repeat code. You use inheritance or composition. Remember composition. And third, polymorphism. In Python, as in other languages, we can basically use objects of different type because they expose a similar interface. Look at the triangle and the rectangle and the circle. They expose the same thing, the area. As long as I'm interested in the area, I don't care about the class. So in Python, generally speaking, we don't care that much about the type. We care about the behavior. We don't want to know if something is a list. We want to know if something behaves like a list, usually. Then we have type hinting because it's useful sometimes, but yeah, that's another thing. Let me read the question sample shapes. Oh yeah, right, Nikki. Definitely we can create a base shape for triangle and where is it? For triangle rectangle. It might make sense. So I don't know if I probably wouldn't. I don't know if I would do this in some code. It depends, In this case, I would probably, yeah, maybe inherit a bit. But you see what happens if you define the base shape and you want to specify what init does. It doesn't work for circle. So you see, again, you have to decide if you want to use inheritance or not. So yes, you can do many things. It might make sense. It might also not make sense. So yeah, I don't have a solution. It depends on the case. Okay, but let's discuss about this. I'm available whenever you want. Speaking of this, wrapping up. I hope you enjoyed the workshop. I know I went a bit fast on some things. The code is available. The posts the workshop comes from are available on my blog. I am available. Ping me on Twitter. I'm unfortunately not being here for the networking later because I have to work and my people in my office are waiting for me. So I'm just, switching context. But I'm available. Really ping me. I made myself a point of answering whoever gets in touch with me on Twitter or email. If you enjoy the workshop and you want, for example, me to give it to another community, maybe a local community or another conference, ping me. I'm always available. If it's for the community, if it's for the conferences or things like that, it's for free. I'm definitely more than happy to contribute to the community. I really hope you enjoyed it. And thank you. Thank you very much again.